Radhe everyone. So like today will discussing about the CPU schedule algorithm. So yesterday we have discussed about the types, like we have some primitive, we have non-primitives. So we have discussed these types. Like in primitive we have SRTF, that is shortest running type first, LRTF, round robin. Round robin is most like it is very much important in terms of exams, in terms of interviews also it was asked. Priority based, and in non-preemptive we have FCFS, SCF, IGF. There are multiple, so but these are very much important, like related to your exams. Okay, so in non-preemptive there is a difference, like non-preemptive and preemptive. The term with both these terms have some meaning, and that meaning is very much essential to understand. So in non-preemptive, the majorly the algorithm comes inside non-preemptives where there is no interruption in the middle of any process. Like there are some process going on. Okay, like process one, process two, process three. These three processes are going. Now we have to execute one by one. So there is a condition, like if process 1 is not executed till then p2, process number 2 and process number 3 will not continue. Means process 1 should be completed first. Without completing process 1 we can't initiate process 2, process 3. Okay, so this is non-preemptive. So the term itself says non-preemptive. Means non-preemptive means you are not preempting something, means you are not like it is not a accurate meaning which I'm telling you. The non-preemptive, it is only a way to remember it. So non-preemptive means not allowing to another process. So if p1 is running, p1 is executing. In operating system term we generally says executing. So if p1 is executing, so p2, p3 or any process can't take its place. Even if its priority is higher, doesn't matter. If p1 is executing, so till the complete execution of process p1, p2, p3, p4, any process does not uh, does not even start. Okay, so for example, if p1 is executing, so till then p1 has not completed is, or p1 has not terminated, till then p2, p3, no any process can come. Even if the priority is higher, priority is lower, doesn't come. If p1 is running, or a higher priority process comes, like p1 is running, a p2 process comes which has a higher priority than p1. So, in case of non-preemption algorithm, this will not happen, that P1 which is currently executing and P2 which came for the execution have a higher priority as compared to P1. So, in case of non-preemption, it will not occur like P1 will terminate without completing its execution and P2 will start. No, this will happen in the case of preemptive, where we are preempting. See, this preemptive, non-preemptive, I am just telling these things, just you can remember, like non-preemption, we are not permitting. So, we are non-permitting. We are not permitting. The process which is currently executing will complete its termination after another process will go. But in preemption, we are permitting. We are permitting. If P1 is currently executing and P2 process came, which has a higher priority than P1, so in case of preemptive, we will allow it. Okay, but in non-preemption, we will not allow. So for your remembrance, for your clear understanding, and for your exam perspective, for your understanding purposes, for your interview purpose, you can learn this thing, or you can understand it in non-preemption. Non-preemptive means we are not permitting. We are not permitting. In preemptive, we are permitting. So if another process, a higher priority process came, so we will allow it to execute. Okay, in preemptive. In non-preemptive, we know it is non-preemption means not permit, we will not allow. If there is a process which has a higher priority as compared to the process which is currently executing, we will not allow. So this is about the non-preemption. So this is the basic difference between preemptive and non-preemptive. And in we'll see now these algorithms in detail. Till then, see these different time which in CPU schedule. Now these times are very much important. We'll use them in the these upcoming algorithms. Okay. So first is like we have arrival time. So it is the time at which process enters in a ready queue. Now what is this ready queue? We'll see it early in upcoming videos, but till then you just know what is this arrival time. So the time at which process enters in the ready queue. Okay, like the ready queue, you know, if you have learned about the, if you have think about if you have listened about these data structures track queue. So queue, you know, is basically a line. Okay, it's simply a line which follows a FIFO principle, that is first in first out, which comes first will get first out. So there is a ready queue means you can say a line. So in line when you are entering, that is your arrival time. Okay, burst time. So burst time. See, burst time is basically the time it is mentioned like burst time, but it is not a time. See, there is a difference between time and duration. Duration is basically like we say half duration. Okay, one hour duration, half hour duration, 2 hour duration. Okay, like in 1 hour duration we have 60 minutes. So duration is the another thing, time is the another thing. Duration is basically a period of time. Okay, like we have half hour, we have 1 hour, we have 2 hour, we have 60 minutes, we have 30 minutes, we have 40 minutes. This is the duration. And time is basically a point of like we are talking about a instance. Okay, like at 10:30, at accurate 10:30 time, I'm arriving at 10:30 and I'm arriving and reaching at 10:30 and 10:40, 10:50 at 10 o'clock. So it is a time and duration is basically 30 minutes, 40 minutes, 50 minutes. This is basically the duration. Getting? So burst time is basically not a time, it's a duration. Now what is this? It is a time which is required by a process to get execute on a service. So it is a time required by a process to get execute. So to get execute on CPU, so this is the basically a time duration. Okay, by a process to get execute. So execute होने में जो time लगता है, it is a burst time. Next is completion time. So the name itself suggests what is completion time. So the time at which the process completes the execution, that will be a completion time. See, if I came or if I arrive at 10:30 in the ready queue, so my arrival time will be 10:30. And if I terminate or if I am leaving, I have completed my execution at 10:40. Like basically it takes 10 minutes time. So 10 minutes time from 10:30 to 10:40 is our burst time. Arrival time is 10:30 and our completion time is 10:40. Like 10:40 I'm just completing, I'm just terminating because I have completed my execution. So 10:40 is my completion time. Turnaround time basically completion time and minus arrival time. So completion time and minus arrival time is basically a turnaround. Okay. Next is waiting time. So turnaround time minus burst time. So basically time spent in the ready queue is basically my waiting time. So turnaround time, I have my turnaround time and I have my burst time. So these are simply formula for turnaround time. You have to you have completion time minus your arrival time. For waiting, you have to do turnaround time minus burst time, and this is the time which you have spent in the ready queue. This is your waiting time. Okay. Now another term is response time. So the time at which a process get CPU first time minus arrival time. Okay, see, I have entered in the ready queue, but I have not received a process. Like I have not started my execution. See, entering into a ready queue does not mean that I have started my execution. No, I'll start my execution once I receive, once a CPU, once CPU receive me. Okay, once I get a CPU, then I can execute. Because execution is what? Basically a kind of computation, a kind of logical computation basically. Okay, and that will be done only with the help of CPU. Okay, that is a CPU, that is a arithmetical logical unit, and memory unit, you know this is about CPU. Okay, so that can only be done when I get the CPU. So my response time is when I get the CPU first time minus my arrival time. So that is a response time. See, if I arrived at 10:30 in a ready queue, okay, and after 10:30 I am getting CPU for the first time at 10:32. At 10:32, so 10:32 minus 10:30 means from 32 to 30. I have 2 minutes in mid. Okay, I have 2 minutes as a difference. So 2 minute is my response time. Getting my point. So 2 minute is basically response time. Okay, so this is about the times. So note, in case of non-preemption, response time is equal to waiting time. You this statement will get clear when you will start solving the numericals, or when we see these examples. Okay, so this is all about the times. In from the next video we'll see these algorithms. Okay, with the help of their numericals we'll get a clear understanding. So you'll also see the advantages, disadvantages. These are the contents which I add on during my exams, because I just analyzed the previous years. So I found that the advantages and disadvantages were also asked in 2 marks, 3 marks, 4 marks. Okay, so I just add on these little things. So we'll discuss each algorithm, FCFS, and everything about, like, see, for SGF we'll discuss advantage, disadvantage. These were generally asked in the exams. Okay, so for your exam, these notes are well maintained. See, round robin we have, so advantage, disadvantage, how it works, everything, and then some important point, and like you'll get uh, each and every understanding. Okay, okay. So for this video, okay, thank you.